हेलो, सॉरी बेटा। मैंने गलत की डाल दी थी और मैं गलत की डाल के सेशन स्टार्ट करके बैठा हुआ था कि सेशन स्टार्ट हो गया है। सॉरी, गलत की डाल दी थी। टेक्निकल प्रॉब्लम, यहां पे मुझे दिखाई नहीं दिया था। हाँ, सर ने क्लास स्टार्ट कर दिया है। अब आ रही है आवाज आपको? यस। नाउ आई एम ऑडिबल एंड आई एम विजिबल। ठीक है। गलत की डाल के मैंने क्लास स्टार्ट कर दी थी तो इस वजह से गड़बड़ हो गई। सॉरी सॉरी सॉरी। तो लेट्स बिगिन ओवर विद द सेशन। आई होप आपको सचिन सर की क्लास के बाद थोड़ा सा गैप भी मिल गया था। गुड इवनिंग, आई एम परफेक्टली फाइन। सॉलिड स्टेट का सेशन कल है बेटा। बहुत लेट हुआ है, सर नहीं आए। अब मुझे पता चल गया, मैं आ गया हूं। सबको बता दीजिए मैं आ चुका हूं। सेशन का मैंने लिंक भी भेज दिया था आपको। एंड दिस इज व्हाट वी हैव एज एलिक्सर ड्रॉपर बैच। दिस इज व्हाट यू ऑलरेडी नो। ज्वाइन कर लीजिएगा फटाफट इसको। और अब ये बैच शुरू हो रहा है 16th ऑफ अगस्त से। थोड़ा सा डिले कर दिया हमने इस बैच को, तब तक हम बहुत सारी चीजें करने वाले हैं। सो लेट्स बिगिन। और हमें केमिकल काइनेटिक्स का भी सेशन करना है, ये एनसीईआरटी का भी सेशन करना है हमें। ये मुझे नहीं पता ये क्या गड़बड़ हो जाती है। ओके। तो आज की सुबह की क्लास के अंदर व्हाट वी हैव डन इन द मॉर्निंग क्लास इज वी हैव टॉक्ड अबाउट द डिफरेंट टाइप्स ऑफ रिएक्शंस, वी हैव टॉक्ड अबाउट डिफरेंट सेशंस, and we have talked about what is the order, what is the molecularity, which is the session, the things. And now we are going to talk about something called the integrated rate laws. So we are now going to talk about the integrated rate laws, and hopefully आज हम chemical kinetics का पूरा सेशन एंड कर देंगे, पूरा कोर्स एंड कर देंगे। क्लियर? सो व्हेन यू टॉक अबाउट द इंटीग्रेटेड रेट लॉज, ये बहुत ज्यादा इंपॉर्टेंट है। इनके बारे में पूरा का पूरा हमें समझना है, करना है। हमारे पास पूरे के पूरे 3 घंटे हैं, शाम को 7 बजे तक का सेशन हमारे पास है। तो आज हम थॉरोली केमिकल काइनेटिक्स खत्म कर देंगे विद एनसीईआरटी रीडिंग एज वेल। सो लेट्स टॉक अबाउट द इंटीग्रेटेड रेट लॉ। अब इंटीग्रेटेड रेट लॉ के अंदर हमारे पास बहुत सीधा सीधा है। वी आर गोइंग टू टॉक अबाउट द जीरो ऑर्डर रिएक्शन, वी आर गोइंग टू टॉक अबाउट द फर्स्ट ऑर्डर रिएक्शन, वी आर गोइंग टू टॉक अबाउट द सेकंड ऑर्डर रिएक्शन। दैट्स व्हाट वी आर गोइंग टू टॉक अबाउट। नहीं, हम सिर्फ जीरो और फर्स्ट ऑर्डर रिएक्शन की बात करेंगे। सेकंड ऑर्डर रिएक्शन हमारे कोर्स में नहीं है। सो वी आर ओनली गोइंग टू टॉक अबाउट द जीरो एंड द फर्स्ट ऑर्डर रिएक्शन। नाउ लेट्स टॉक अबाउट द, अच्छा, इससे पहले कि जब हम इंटीग्रेटेड रेट लॉ की बात करें, कुछ चीजें यू नीड टू अंडरस्टैंड। बाद में स्टूडेंट कंफ्यूज हो जाते हैं कि पता नहीं ये कहां से आया वो कहां से आया। सो नाउ वी आर गोइंग टू टॉक अबाउट that how the things are taken for the zero order reaction and the first order reaction. The very first thing, the reaction is A giving products. The stoichiometric coefficient of A is 1. You very well know that we can always balance the equation such that the stoichiometric coefficient can be whatever we require and we consider. Now, the stoichiometric coefficient is always going to be 1. Fine. Okay. Next, considered stoichiometric coefficient is 1. Next, we have this is the reaction stoichiometric coefficient 1. So, when we talk about the rate of a reaction, the differential rate law will always be minus dA by dt. So, rate is going to be minus dA by dt. So, that is the very important thing. And further, the rate for the nth order will be equal to K into concentration of A raised to power N. There is only one reactant. Anyone has any confusion with this? So we are going to talk about only one reactant, and we are going to talk about the concentration as rate is equal to K raised to power A raised to power N only. Fine. So now Let's get along with hold on here, something is wrong. Why is it happening? I'll just need to take care of it. Okay. So this is what we have as the thing. So now let's talk about the zero order reaction. Let's talk about the zero order reaction. The very first thing, the reaction is A gives us product. The rate by the differential rate law is going to be minus D concentration of A by D. Okay. The rate according to the rate law is going to be equal to K into concentration of A raised to power 0. This is a zero order reaction. Fine. Now these two rates are same. So we can equate them. We get minus dA by dt is equal to K. Minus dA by dt equal to K. So this is what we get here. Clear? Fine? Okay. Now, to integrate it, we have to separate the variables. We have to take the variables to a different part. So what do we get is we get dA is equal to minus K dt. dA is equal to minus K dt. Integral. We are going to talk about the definite integral. We are going to do it from A naught to AT. Now, what is A naught? A naught is the initial concentration, or you may even tell it to be the specified concentration. Specified concentration would mean the concentration which must be consumed for the reaction to be considered completed. AT is concentration at any time. Or you may consider it to be the final time or whatever time we are talking about. This is the concentration at time t. Now, whenever we write this AT, this is actually this A. This A is the time at time t. This is the concentration at time t. Then we have T1, we have T2, and we may have T0. T0 is what we have as initial time, which we normally consider as 0. So most often when we are integrating it, we consider in time from 0 to t. That is A naught to AT. A naught is the initial concentration. We are integrating from A naught. So we are going to take T as 0. Is this very clear? So here we have dA is equal to integral 0 to t minus k dt. Right. Now integral of dA from A naught to AT is equal to AT minus A naught. This is what we have as a definite integral from a given value. And that would be equal to minus KT. Now this is the integration that we get. This can be written in many ways. I can write it as AT is equal to A naught minus KT. Clear? Now, these are the equations that you need to understand. And now we are going to talk about the graphs. There are three graphs that we are going to draw. The first graph is what we talk about as rate versus the concentration. As the concentration is changed, how would the rate change? Clear? Second, we are going to talk about the change of the concentration with respect to time. You may even consider it as AT. Clear? That is, as the time changes, how the concentration is going to change. And the third graph is going to be rate versus time. How the rate changes with time. So these are the three graphs that we talk about. Okay. Now, let's see how it moves. Now, before we talk about any of the graph, we need to know what are the equation that we are trying to plot. So whatever the equation that we have, that's what we need to plot. So what are the equation? Here, the rate versus A, it is going to be rate is equal to K into concentration of A raised to power 0. Now, since it is A raised to power 0, the rate is simply equal to K. So when we plot this particular graph, this graph is going to become a straight line parallel to the x-axis. This intercept is K, the rate constant. Now, when we talk about the concentration with respect to time, the equation is AT is equal to A naught minus KT. Now, this equation, if we write it as AT is equal to A naught minus KT, this is an equation of a straight line, that is y is equal to C minus mx. Now, minus m is the slope of the line. It has a negative slope, and x is the variable, c is the intercept. So the graph would go in this manner. Okay. Now, this part is what we have as A naught. The slope is going to be minus k. Confusion? अगर है तो बताओ. Okay. Next, we have rate versus time. Now, rate is equal to k into A raised to power 0. Now, rate is equal to K into concentration of A is equal to A naught minus KT, but raised to power 0. So this is the relation with the time. But time again is not affecting the rate of the reaction. So zero order reaction, the rate does not change with time. Again, it is going to remain a constant. And this value is again K. So that is the graph of the zero order reaction with respect to the various factors. Anybody has to ask anything? Anyone has anything to ask? प्रेरणा, व्हाट एग्जैक्टली इट इज टू बी सेड? टेल मी। ग्राफ्स बता तो दिए, क्या पूछना है इसमें? This graph is of the constant rate with respect to the concentration. This is the graph of the concentration with respect to time. This is the graph of rate with respect to time. This is the equation for which we have made the graph. This is the equation for which we have made this graph. And this is the equation for which we have made this particular graph. The rate is equal to K. Any doubts? Minus M, that is the slope. The equation for the straight line is y is equal to mx plus c. Now here it is y is equal to minus mx plus c. So minus m is the slope. That is the equation of a straight line, isn't it? Is that okay, Prerna? Okay? सर मैं रिकॉर्डिंग देख लूंगा, थैंक्स सर, बाय। ओके ऋतिक, बाद में रिकॉर्डिंग देख लेना। कल सुबह 10 बजे क्लास है सॉलिड स्टेट की, उसमें जरूर आ जाना। नाउ वी टॉक अबाउट समथिंग कॉल्ड द हाफ लाइफ। Half life. What is the half life? Let us understand. The time required for the specified initial concentration of the reactant to become half. That is the time required for half completion of the reaction. Now this T half is generally represented as T half, or you can write it as T 0.5. Fine. This is how we write the half-life of reaction. Perfect, Ritik. Welcome. Is that clear? So this is T 0.5. So that is what we have as the half-life of the reaction. Now, at T 0.5, A T is equal to A naught by 2. That is what you have to remember, that the concentration of the reactant becomes half of the initial concentration at half-life. Is it clear? Any kind of doubts? So that is what we have as the half-life of the reaction. Now let's talk about the half-life of a zero-order reaction. Half-life of a zero-order reaction. Half-life of a zero-order reaction. ठीक है? Buffering? नहीं अनन्या, there is no buffering. We have the equation as AT is equal to A naught minus KT. At half-life, A naught by 2 is equal to A naught minus K T 0.5. But why am I not looking at any lag? My session is going perfectly fine. Okay. That means T 0.5 is equal to mm, A naught minus A naught by 2 whole divided by K. So that will turn out to be A naught by 2K. Any confusions? Clear? A naught by 2K. Now what does it mean? It simply means that the half-life of reaction increases with increase in initial concentration. The half-life of a reaction increases with increase in the initial concentration. If you double up the initial concentration, the half-life also is going to double. Is this clear? Now, once we have talked about the half-life of a zero-order reaction, we can even talk about the complete life of a zero-order reaction. We can talk about the complete life of a zero-order reaction. Now, at complete life, AT is equal to 0. That is, all entire reactant has been consumed. Then only we can talk about it as a complete life of the zero-order reaction. Okay. So here it is going to become 0. So what we are going to get is equation is AT is equal to A naught minus KT. So here it is 0 is equal to A naught minus KT 1.0, 0.5, 1.0 complete. So T 1.0 is equal to A naught minus 0 by K. So that's equal to A naught by K. Now that simply means that T 1.0 is equal to 2 multiplied by T 0.5. Understand it thoroughly. For a zero order reaction, for a zero order reaction, time required for half of the reaction to complete is half of the time required for completion of reaction. Clear? So that is what we have as half-life of the reaction. Atika Mariam, could you please name the lectures like 1, 2, 3, sir, because it's very difficult when we see the recording. Beta, I believe the topics are there and you can see the dates. Well, next time onwards, I'll write a small L1, L2 also. Okay, from tomorrow onwards, we are going to write it as L1, L2 as well. Okay, fine. But that should not make any problem. It is already in sequence only. Fine. So that is what we have as for a zero order reaction. And this particular statement is valid only for a zero order reaction. It is not valid for any other reaction. Valid only for zero order reaction. Anybody has anything to ask here? Anyone has anything to ask here? Now let's get along with the first order reaction. Let us get along with the first order reaction. In case of the first order reaction, the reaction is again A gives us the product. Okay. Now, the first equation is rate is equal to minus dA by dt. This is the differential rate. Okay. Second equation says rate is equal to K into concentration of A. No confusions here. And now we equate the two. We get minus dA by dt is equal to K into concentration of A. Yeah. So we get dA divided by the concentration of A is equal to minus K dt. Now we are going to integrate it. Integral of A naught to AT dA by dt, but dA by concentration of A is equal to integral of 0 to t minus K dt. Integral of 1 by x dx is equal to ln x. So integral of 1 by a dA will be equal to ln a. Okay. So here we get it as ln a t minus ln a naught is equal to minus k t. This is the answer that we get. Anyone has any confusions with that? Anyone has any confusions with that? We can write it as ln a t by a naught is equal to minus kt. This is how we can write the logs. Tirthraj, we are talking about definite integrals. Definite integrals, there is no c because c gets cancelled out. Subtraction है ना? Here we have ln at minus ln a naught. यहाँ पर भी ये ln at plus c है. ये ln a naught plus c है. So when we are having ln at plus c minus ln a naught plus c, the c and c get cancelled out. That is why the c is not there. The constant gets cancelled out. Is that clear, Tirthraj? Okay. So this is what we have as a definite integral. Definite integral, there is no constant of integration. That gets cancelled out. Okay. So this is what we get. Now we can put it in exponent. Now this is what we have. This is the equation number 1. This can be the equation number 2. And we can put it as an exponent. We can get at by a naught is equal to e raised to power minus kt. Or we can write it as at is equal to a naught e raised to power minus kt. Is this clear? Write it down. Anything you want to ask here? Okay, so these equations later. Then we can have another equation. You know that ln x is equal to 2.303 log x. So ln at by a naught is equal to minus kt. That would be equal to log at by a naught is equal to minus kt upon 2.303. Okay. And further, log x is equal to minus log 1 by x. If we turn it around, we can get it as log a naught by at is equal to kt upon 2.303. Radhika, yes, you will have to learn this particular equation. Welcome, Akshay. How are you? Yeah. Now let's talk about the graphs. Prerna, be very careful about the graphs. So again, we are going to talk about the same three graphs. Okay. आराम से 3 पेज पे करते हैं 3 graphs. The first graph is rate versus concentration. Okay. Now, rate is equal to K into concentration of A. As the concentration of A increases, the rate also increases linearly. This is directly proportional. Now, this is the graph of a straight line passing through the origin. So the graph goes this way. Clear? And the slope is K, a positive slope. As the concentration of the reactant increases, the rate of the reaction also increases linearly. Okay. Next graph. Next graph, we talk about the concentration AT with respect to time. Okay. Now, what is the equation for this particular graph? The equation for this particular graph is AT is equal to A naught e raised to power minus KT. This is the equation for this particular graph. Now, this is an exponential equation. This is an exponential equation. And now when we talk about this particular equation, the graph would go like this. The graph would go like this. So as the time passes, the concentration of the reactant drastically decreases, but then the decrease becomes less. Okay. Next, we talk about the graph of rate versus time. You can talk about the graph of rate versus time. Now, when we talk about the rate, we know that rate is equal to K into concentration of A. Now, that would be equal to K into A naught e raised to power minus KT. So that actually will turn out to be rate is equal to Ka naught e raised to power minus KT. Now, this again is a constant, or you can say it is going to be the intercept. So the graph again goes this way. Is this clear? Any confusions, anybody? Is it clear? We can even have one more reaction, one more graph. Now, this graph can be of log AT with T. Or you can have the graph of ln AT with T. Doesn't make a difference, only the slope is going to become different with either K by 2.303 or K. The graph could be, the equation could be ln AT is equal to ln A naught minus KT, or it could be ln log AT is equal to log A naught minus KT upon 2.303. So in both the cases, the graph is going to be a straight line with a slope of either minus K or minus K upon 2.303. Any kind of confusions? Okay? Anybody has to ask anything about any of these graphs? So now let's talk about the half-life of a first order reaction. Half-life of a first order reaction. Now we have the equation as ln A T by A naught is equal to minus KT. Now this is the equation that we have done. We can write it as ln A naught by AT is equal to plus KT. Fine. At half-life, it is going to become ln A naught upon A naught by 2 is equal to plus KT 0.5. Any confusions here? Okay. So ln A naught get cancelled out. ln 2 is equal to KT 0.5. So T 0.5, that is the half-life, is equal to ln 2 by K. Any confusions? Then T 0.5 is also going to be equal to 2.303 log 2 by K. Any problems? Now log 2 is 0.301. So it is going to be 2.303 into 0.3 by K. Okay. And this value is equal to 0.693 by K. Any problems? Let's have a question. Which of these expressions gives the half-life of a first order reaction? A 0.693 by K, B ln 2 by K, C 2.303 log 2 by K, D all of these. Answer. Answer. Which one is the answer? Very easy. Perfect. Now let's have a question more. Question. For a first order reaction having half life 10 minutes, calculate the time required for it to be 90% completed. For a first order reaction having the half-life 10 minutes, calculate the time required for it to be 90% completed. Now this question I am going to do. And then I'm going to ask you three more questions that you will have to do. And you have to give me the answer very fast. Now for the answer to this question, A naught, let us say it is equal to A naught only. Fine. A T is equal to A naught minus 0.9 A naught, 90% completed. Clear? So AT is equal to 0.1 A naught. Fine. Now, T half is equal to 10 minutes. We can have the expression of T half is equal to 2.303 into 0.3 by K. Okay. This we can take as the expression of T half. Now, K will be equal to 2.303 into 0.3 by T half. Now we can substitute in the equation. We have log A naught by AT is equal to KT upon 2.303. So we have log A naught upon 0.1 A naught equal to K. The value of K is 2.303 into 0.3 into t 0.9, okay, divided by 2.303. We can just cancel them out. So we get log 10. 1 by 0.1 is 10 is equal to 0.3 t 0.9. So t 0.9 is equal to log 10 is 1 upon 0.3. Oh, t half. I forgot to write t half here. Into t half, and that becomes equal to 3.33 t half. Now t half is 10 minutes, so it is going to become 3.33 into 10. 3.33 into 10, and that's equal to 33.3 minutes. Understood? Copy it. Okay, then have the next question. Answer. 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 You have noted it down, but where is the answer? If you have noted it down, then in that case, you just have to substitute. Now here, A naught and AT is equal to 0.01 A naught. 2 minutes, Ananya. Answer. Answer. Yep. Everybody got it? Log 1 by 0.01 is equal to 2.303 into 0.3 divided by 10 into T 0.99. So this comes out to be 2 is equal to 2.303 into 2.303. So 2.303 gets cancelled out. And we get it as 0.3 by 10 T 0.99. So T 0.99 is equal to 20 by 0.3 is equal to 66.66 minutes. Is this clear? Everybody got it? Next question. Answer. Answer. Akshay Thakur has got the answer. Where are the others? The answer is 100. Okay. Let's talk about the next question. 93.75% completed. And now use K is equal to 2.303 log 2 by T half. Use this expression for K. That will make it easier. I don't say that it's not going to be answerable. In this case, you have log 100 by 6.25. Okay, whatever you want to call it. That's going to be equal to 2.303 log 2 by T half into T 93.75 by 2.303. Okay, this goes here, this goes here, this goes here, this goes 16. So this is 4 log 2 is equal to log 2 upon T half into T 93.75. Log 2 and log 2 get cancelled out. T 93.75 is equal to 4 into T half. Any problems? Everybody clear? Everyone clear it? Okay. So that was the simple question of a first order reaction half-life. Now, having talked about this half-life, we can even talk about the second order reaction. But no need to do it. It's not in our course. Clear? Now, having talked about this, now we are going to talk about the experimental determination of order. How do we determine the order of reaction experimentally? अनन्या क्या समझ में नहीं आया बेटा ये देखो क्या समझ में नहीं आया इसमें पूछो It is the same thing we have done same thing which we have done in the past two questions third line which third line this one do it Ananya you do it and you will be able to find it out A naught is equal to 100 AT is equal to 100 minus 93.75 So it is equal to 6.25. Okay. Log A naught by AT is equal to log of 100 upon 6.25, and that will be equal to KT upon 2.303, and KT is 93.75. Okay. Now log 100 by 6.25 is log 16 is equal to 2.303 log 2 upon T half multiplied by T 93.75 upon 2.303. Got it? Can you solve it now, Ananya? Log 16 is 4 log 2. How it is? Because 16 is equal to 2 raised to power 4. So log 16 is equal to log 2 raised to power 4. This power goes out of the log and we get log 16 is equal to 4 log 2. Is this clear? Okay. Now let's find out the order. Let's determine the order. Now the very first method to determine the order experimentally is called the half-life method. The half-life method. Let's solve this. The half-life method would say that we have, for a first order reaction, let's say we say zero order. T half is equal to A naught by 2K. B first order T half is equal to 0.693 by K. Now, if we talk about the second order, we have not done it, but T half is equal to 1 upon Ka naught. Okay. So what we find is that T half is proportional to the concentration, the initial concentration raised to power 1 minus n. See it? Is this clear? So what we can find is that if we have for concentration A1, T half is equal to T1. For concentration A2, T half is equal to T2. Okay. So T1 by T2 is equal to A1 by A2 raised to power 1 minus n, where n is the order. Okay. And A1 and A2 are the two initial concentrations. Anyone has to ask anything? Have you noted it down? Okay, then let's have a question. Half-life of a reaction. A gives us product is 10 minutes when concentration of A is equal to 0.1 molar. Okay. T half becomes 40 minutes when concentration of A is equal to 0.05 molar. Okay. What is the answer? Answer. A1 by A2 is equal to T1 by T2 raised to power 1 minus n. A1 value is 0.1, A2 value is 0.05, is equal to T1 value is 10 minutes, T2 value is 40 minutes raised to power 1 minus n. You have to find the value of n. Ananya, did you solve it? No, you didn't. Solve it and give me the answer. And whoever has not liked the session, go ahead and like it. That will become 2 is equal to. I've done it other way around. It should be here, 1 minus n. So 2 raised to power 1 minus n is equal to 1 by 4. Okay, so 2 raised to power 1 minus n is equal to 2 raised to power minus 2. So 1 minus n is equal to minus 2, n is equal to 3. Is this clear? Okay, fine. So that is what we have as half-life method of determining the order of the reaction. Now we can talk about another method, and that is what we call as initial rate method. Initial rate method. Now this is a very simple method, and this is the most common used method when we talk about the rate of a reaction or the order of a reaction. And when we talk about the initial rate method, we have to make a table. In this table, and we are going to talk about the two reactants. We have A of A plus B of B giving us the products. Okay, so here we have the concentration of A, and here we have the concentration of B. And then we have something like rate. Now rate is equal to K into concentration of A raised to power alpha, concentration of B raised to power beta, where alpha and beta are the order with respect to A and B. Now when we talk about the A, let's say we have the concentration of A as A1, initial concentration of A as A1 and concentration of B as B1. So rate R1 would be equal to K into A1 raised to power alpha, B1 raised to power beta. Then we can have concentration of A as A2 and B we can keep it as B1. So rate 2 will be equal to K into concentration of A2 raised to power alpha, B1 raised to power beta. And then we can have again A1 and this could be B2. We have R3 is equal to K A1 raised to power alpha, B2 raised to power beta. And then we can have A2. This is B2. R4 is equal to K into A2 raised to power alpha and B2 raised to power beta. You need to understand that whatever is the number of reactant, we have to have one more observation. Since there are two reactants, we require three observation minimum. Any confusions here? Now you can actually see that if I have R1 upon R2, that becomes equal to K and K cancel out, B1 and B1 get cancelled out. It becomes A1 by A2 raised to power alpha. Now R1, R2 are determined experimentally, A1 and A2 are determined experimentally. So alpha is the only thing which is required. In the same manner, if you talk about A1 upon R1 upon R3, you can calculate beta. Is this clear? So you have to check what gets cancelled out and what is observed. Have you copied it down? Okay, then let's have the question. Concentration of A, 0.1, 0.2, 0.3. Concentration of B, 0.1, 0.2, 0.1. Rate, 3 into 10 raised to power minus 5, 2.4 into 10 raised to power minus 4, 2.7 into 10 raised to power minus 4. Find out the order with respect to A and B. 3-minute break. Okay, take 3-minute break. It is 5:44. Answer. Okay, so we begin. Break over. Give me the answer. The question is right in front of you. Answer. Answer. First order reaction with respect to. I have got the two orders. You have to give me alpha and beta. You don't have to just give me alpha. You have to give me alpha and beta. Question is in front of you, beta. Ananya, you just have to give me the alpha and beta. So what we do is we take it R1 by R3. R1 by R3 would mean 3 into 10 raised to power minus 5 divided by 2.7 into 10 raised to power minus 4, and that's equal to k into 0.1 raised to power alpha into 0.1 raised to power beta divided by k into 0.3 raised to power alpha into 0.1 raised to power beta. Now, this gets cancelled, this gets cancelled, and what we find is 1 by 9 is equal to 1 by 3 raised to power alpha. So this means alpha is equal to 2. Any confusions? Now what you do is you get it as R1 by R2. Now that would be equal to 3 into 10 raised to power minus 5 upon 2.4 into 10 raised to power minus 4. This is equal to k into 0.1 raised to power 2. Okay, we are putting the value of alpha here into 0.1 raised to power beta divided by k into 0.2 raised to power 2 into 0.2 raised to power beta. Now, can you solve and give me the answer of beta? Fine. So that is how we determine the order of a reaction. Clear? And after that, we are now going to talk about the effect of nature, temperature, and catalyst. Nature, temperature, and catalyst. That's what we are going to talk about today. Okay. Beta is equal to 1. Priyanshu, beta is 1, not -1. How did you get it -1? This is going to be 1 by 8 is equal to 1 by 2 raised to power beta. Okay. Or rather, I should say 1 by 2 raised to power beta nahi, into 1 by 2 raised to power 2. So this part gets cancelled out and we get 1 by 2 is equal to 1 by 2 raised to power beta. So beta turns out to be 1. Priyanshu, it's not -1, it's 1. Is this clear? So let's talk about the reaction. So here we have something like the Arrhenius equation. So I'll go along with the Arrhenius equation only. Arrhenius equation. Now, when we talk about the Arrhenius equation, now we are going to write the equation in a different manner. We have rate is equal to K into concentration of reactants raised to power n. Now, what we do is we take the concentration of the reactants is equal to 1. So, rate becomes equal to K. Rate becomes equal to K. Fine. So, rate and K can be used interchangeably. Fine. So now to talk about the Arrhenius equation. Arrhenius equation says K, or rate, is equal to A e raised to power minus EA by RT. K is equal to A raised to power e raised to power minus EA by RT. Now what this EA is? EA is the activation energy. Okay. T obviously is the temperature, and A is the Arrhenius factor. You may call it a pre-exponential factor, or you may call it as the collision frequency. Okay, I'll just tell you what exactly is this. So these are the factors. Now this part is actually a dimensionless fraction. Okay, this is a dimensionless fraction. Now this e raised to power minus EA by RT is equal to the fraction of collisions that are effective. The fractions of collisions that are effective. That is how many collisions will be able to give us the product. Have you noted it down? Clear? Now let's talk about a graph. Here we have again the energy, and here we have the reaction coordinate. You can simply say reaction. We have already talked about this graph that the reaction goes like this. Here we have energy of the reactant, here we have the energy of the product, and the graph could be something like this also. The graph could be something like this also. Now, this is what we have as the transition state, and this is also called the threshold. This is the threshold. Now, what is the meaning of the threshold? Threshold energy. The minimum energy that a reactant must possess to react. This is what we call as the threshold energy. Now, as you can very well see that the reactant must acquire some energy. This much energy it needs to reach the threshold. Okay. Now, this energy is called the activation energy. Clear? Now, we have the definition of activation energy. Activation energy is the minimum energy a reactant needs. Needs. Remember, I should possess, let us say, 10 lakh rupees to buy a car. Okay, I must possess 10 lakh rupees to buy a car. How much money do I need? I have 7 lakhs. I need 3 lakhs. So 3 lakh is what I need, and 10 lakh is what I need to possess to buy a car. Is it okay? To reach threshold. Okay. Now, activation energy is the threshold energy minus energy of reactant. Okay. Now, remember, EA is always greater than zero. That means it is positive. It cannot be negative. It is always required and it cannot be zero. So that is what we have as the threshold energy. Is that clear, Kshitij? Clear, Radhika? Clear, Ananya, Prerna, Tirthraj, Priyanshu, Ananya? Everybody clear? Fine. Now, this is delta H of reaction. This is delta H of reaction. Clear? Now this is one thing. Okay. Now there is one more thing. If I want to reverse a reaction, I'll have to go from product to the reactant. And I'll have to pass through the same transition state. So this would be the activation energy of the backward reaction. This would be the activation energy of the backward reaction. Now this reaction was endothermic. And this reaction is exothermic. Is this clear? Fine. As you can see, the activation energy of the backward reaction is more for exothermic reaction. Is this clear? The activation energy of the backward reaction is more for exothermic reaction. Clear? And you can say E of the backward reaction is actually equal to E of the forward reaction minus delta H of the reaction. For an exothermic reaction, delta H is negative. And so EB will come out to be higher than EA. For an endothermic reaction, delta H is positive. So EB will come out to be less than EA. Is this clear? Fine. Remember this equation. Clear? Now, we have just talked about the graph, and now we need to know about the temperature. With a small increase in temperature, with a small increase in temperature, the rate of reaction increases drastically. Now, why does the rate of the reaction increase drastically? This is because the fraction of molecules having energy greater than threshold increase exponentially. Is this clear? The fraction of molecules having energy greater than the threshold increase exponentially. Clear? So, the number of effective collisions increase exponentially. Number of effective collisions increase exponentially. Clear? So that is how the rate of the reaction increases with increase in temperature. Clear? Now we have something like K is equal to A e raised to power minus EA by RT. If I take the log and I have to take the natural log, ln K would be equal to ln A minus EA by RT. Okay. That could be written as log K is equal to log A minus EA upon 2.303 RT. Any confusions with that? Now let's talk about the effect of temperature. Log K1 is equal to log A minus EA upon 2.303 RT1. Log K2 will be equal to log A minus EA upon 2.303 RT2. So we can have log K2 by K1 is equal to log A would cancel out, and it's going to be EA upon 2.303 R bracket 1 by T1 minus 1 by T2. Is this clear? So what we can see is if T2 is greater than T1, K2 will be greater than K1. So this means for chemical reactions, the rate increases with increase in temperature. Okay, for chemical reaction, the rate increases with increase in temperature. Any kind of doubts? Anything you would like to ask? Okay, let's have a question. Calculate the factor by which the rate of the reaction with EA equal to 50 kilojoule per mole increase when temperature changes from 290 Kelvin to 300 Kelvin. Okay, so you have to find K2 by K1. This is the factor by which the rate would increase when the temperature increases. The equation is going to be log K2 by K1 is equal to EA upon, now 2.303, R can be written as 8.31 or you can write it as 25 by 3. 25 by 3 is a little easy to calculate, but nothing else such. 8.31 into 1 by T1 is 1 by 290 minus 1 by 300. EA value you have to give me the value of K2 by K1 or even you can give me the value of log K2 by K1. Answer. Anish, you have entered the class just now. How can you समझ में आया? कैसे आएगा तुम्हें समझ में? कुछ समझ में नहीं आया. समझने के लिए क्लास में रेगुलर होना पड़ता है बेटा. Okay, Anish says English मुझे इतनी ही आती है. So beta, we don't discuss politics here. So it means we are not gonna discuss your English here. आंसर. इक्वेशन तो समझ में आती है. इक्वेशन तो लिखो. आंसर दो इसका. यूज द कैलकुलेटर. आंसर. आंसर. अनीश. How do I become a legend? By just answering you. You have to give me the answer of the question. Now this value comes out to be approximately 0.3. So log k2 by k1 is equal to 0.3 and k2 by k1 comes out to be 2. So we can say that the rate of a reaction having EA equal to 50 kilojoule doubles with 10-degree rise in temperature. Now this doubles is called temperature coefficient. Temperature coefficient is the factor by which rate of reaction increases. Any kind of doubts? Anybody who has not liked the session, go ahead and like it. Fine. Now what I do is I just make the question a bit different. Same question, but a bit different. What's the difference? EA is 100 kilojoule per mole. Could you give me the answer? Answer. Answer. You solve it, beta. Tirthat, solve it. Then give me the answer. Solve it. Solve it. The same question. The only thing is activation energy has become 100 kilojoules instead of 50. The answer is not 1. Answer is 4. Log K2 by K1 is equal to 0.6. So K2 by K1 is equal to 4. Okay. More is EA. More is effect of temperature. More is temperature coefficient. Is this clear? Okay. We end the class today at this point only. We are going to do some questions today at 8 o'clock, and then we are going to again have this little bit of class, an NCERT reading of chemical kinetics tomorrow. Okay? Okay? We are going to have the NCERT reading by the time you can also read the NCERT. Fine. So this is our biggest offers. We have already the offers here. 2 o'clock, Swati ma'am is going to take the class. 3 o'clock, Sachin Kapur sir has the class. And 4 o'clock, I am having the class. And we have 10 a.m. solid state. So we have 10 a.m. class of solid state. Okay, beta? And make the notes and send it on WhatsApp. I'm waiting for your notes. Thank you. We'll meet at 8 o'clock in the special class of the chemical kinetics. Clear?